When we do the calculus of complex numbers, the rules are very similar to what we've encountered so far when we're doing the calculus of real functions. So if we define a complex number z of x as being made up of a real and an imaginary part, the real is a function of x, the imaginary is a function of x. So we may have z of x, an example, equals 3x squared plus 1 plus 4x cubed I. So here would be my f of x, and here would be my g of x. Obviously, f of x and g of x could be a lot more complicated than just a simple polynomial, but suffice to say that could be an example. When we do the calculus, let's talk about the derivative first. We can say that the derivative with respect to x of the real part of z of x. Now the real part of z of x is the part that does not contain I. In this case it's f of x, so it's simply just the derivative with respect to x of f of x. And that in fact is the real part of the derivative with respect to x of z of x. So you can just find the derivative of the whole function and then just pick out the real, and that is the derivative of the real part. Likewise, the derivative with respect to x of the imaginary part of z of x. This is the derivative with respect to x. Now what is the imaginary part of z of x? The imaginary part is g of x. And that will be equal to the imaginary derivative with respect to x of z of x. Because the imaginary of z of x is equal to g of x. They are the rules for the derivatives. With the integrals, the integral of the real part of z of x dx is equal to the integral of f of x dx, and that's equal to the integral of z of x dx. So the integral of the real part is the integral of f of x, and you can just find the integral of the whole complex numbers, real and imaginary, and then just identify what is the real part. The integral of the imaginary of z of x dx is equal to the integral of the imaginary part that we identified as g of x dx, and that is equal to the integral of z of x dx. Okay, so 4 basic rules when we're doing the calculus of complex numbers.